You start.
Okay, right, sir. Good morning, students. Welcome back to our webinar classes. So this is Balakishan Reddy, JL in Mathematics from Tsrs&Jc Borabanda boys. So yesterday in the previous class, we discussed about what is the probability. So probability. So the probability and the addition probability theorem also there, and the conditional probability and the multiplication probability theorem, and then some problems are there. So we discuss. I'm reminding once again the definitions of the probability. So first definition. So random experiment. Random experiment. So what is a random experiment? We have to define that one. So an experiment that can be repeated any number of times. That can be repeated any number of times in identical conditions. In identical conditions. So an experiment that can be repeated any number of times in identical conditions, that is, all possible outcomes of the experiment are known in advance. So all possible outcomes of the experiment are known in advance. The second condition is there. So that is, the actual outcome in a particular case is not known in advance. The actual outcome in a particular case is not known in advance. So what is the meaning of this? So I'm giving an example. If you're tossing a coin, then you know the result. Then you know the results. So what are they? Head or tail? So that is the first case. And the second case, the actual outcome in a particular case is not known in advance. So we have to toss a coin. Then you don't know what will be happen there. So it will be tail or it will be head. So exactly you don't know. So that is the random experiment. Okay. So otherwise you have to take also die. Okay. So that are the example for the random experiment. So random experiment, you have to know the results. You have to know the results. You have to know the results. And you don't know exactly results. Okay. Next. So this is called as a random experiment. So next, mutually exclusive. Mutually exclusive is nothing but two or more events are said to be mutually exclusive if the occurrence of the one of the events prevents the occurrence of any of other remaining events. Same. So you have to tossing a coin. Then you know that two results, that, and if it will be there, then tail will be prevented by head. So that is the definition of mutually exclusive. So that is nothing but the z1 e2 up to so on ek are said to be mutually exclusive. Then mutually exclusive. Then if e1 intersection ei intersection ej equal to pi for I is not equal to j. So 1 is less than or equal to I and j is less than or equal to k. So something values is there. Okay. Next. So equally likely is nothing but two or more events are said to be equally likely or equally probable. So there is no reason to expect any of them happen preference to others. So equally likely, which is nothing but they have the same probability. So there you don't know. There is no reason to expect any of them happen to preference to others. So if you tossing your coins two times, then you will get two heads also. Two heads will be, and the one head, one tail, one head, like that. So that is the equally likely. So exhaustive, two or more events are said to be exhaustive if the performance of the experiment always results on the occurrence of at least one of them. So that is nothing but if you know the results, then you have to toss the coin, then it will get only one of them. Only one of them. That is the exhaustive. So that is nothing but E1 union, E2 union, up to so on ek. That is nothing but in S. S is nothing but the sample space. So total outcomes. So a probability definition. So if a random experiment results in exhaustive and a mutual exclusive and equally likely elementary events, and m of them are favorable to the happening of an event E, then the probability of occurrence of E is nothing but P of E is defined by P of E equal to m by n. So that is nothing but So here M indicates total favorable cases. Total favorable cases by N is indicates total number of cases. Total number of cases. Okay. So how many times this will be favorable cases is nothing but M. So total cases is nothing but N. That is the probability definition. Okay. These are the definitions. And what is the conditional additional probability theorem? So before that, so you know this one. So the probability of an event must and should lies between the 0 to 1 only. Lies between the 0 to 1 only. So next, addition probability theorem. So addition probability theorem is nothing but just I'm showing an. So this is the if A and B any two events of a random experiment and P is a probability function, then P of A union B equal to P of A plus P of B minus P of A intersection B. So this is the addition probability theorem. So next, conditional. So conditional probability theorem. So conditional probabilities, that is nothing but if A and B two events of a sample space with P of A is not equal to 0, then probability of B after the event A has occurred is called the conditional probability of B. Given A and A is denoted by given A and D and is denoted by P of B by A, that is nothing but P of B by A equal to P of B by A equal to P of A intersection B of P of A intersection B by P of A, that is P of A is not equal to 0. This is a conditional probability theorem. So next, multiplication theorem. So if A and B are any two events of a random experiment with the P of A is greater than 0 and the P of B is also greater than 0, then P of A intersection B equal to P of A into P of B by A. Otherwise, we can write P of A intersection B equal to P of B into P of A by B. Okay. So next. So next, we have to discuss some problems. Now that the probability of the three events, the probabilities of three events, the probabilities of three events. So probability of three events of such that P of A equal to 3 is given, P of B equal to 0.4, P of C equal to 0.8, P of A intersection B equal to 0.08, P of A intersection C equal to 0.28, P of A intersection B intersection C equal to 0.09, P of A union B union C is greater than or equal to 0.75. Show that P of B intersection C lies in the interval 0.23, 0.48. So, he given three events is there. So and I give some values for that one, probability of that one. So then P of A equal to 0.3, P of A equal to 0.3, P of B equal to 0.4, and the P of C equal to 0.8. So P of A intersection B, both will be exist there, that the values, the probability is nothing but 0.8, and the P of A intersection is there, that the probability of A intersection C is nothing but 0.28, both events there. So P of A intersection B intersection C, so that is 0.09. So three events will be there. So then all events A union B union C is greater than or equal to 0.75. So clearly we know that and the probability of an event, probability of an event must and should lies between 0 to 1, must and should lies between 0 to 1. So here, so you give that this is a 0.75, so which is less than 1, which is less than 1, and we have to prove this one. We have to prove this. This is lies between the 0.23, 0.48. Okay. So for that one solution, what is the given? So just write the given values. So P of A equal to P of B equal to P of C, P of A intersection B, P of A intersection C, P of A intersection B intersection C, and the P of A union B union C. So clearly we know that. This is the value. So from the condition. Okay. From the condition, this is the value. So this is nothing but 0 is less than or equal to P of E is less than or equal to 1. 0 is less than or equal to P of E is less than or equal to 1. This is the condition. So probability of an event must and should lies between the 0 to 1. That's why I'm taking this one. So then, so what is the P of A union B? What is the P of A union B? So in the addition probability theorem, we have taken that one, two events is there. So here three events is there. So that's why we have to use P of A union B union C equal to. Okay. So P of A union B union C equal to. So this is the P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. This is the formula. So we have to use this formula. Okay. So we know the all of the values and just we have to substitute there and we have to find this value. We have to find this value. Okay. So this is the formula. And given this is, so this is the condition, this is the condition of probability, that is 0 is less than or equal to P of A union B union C is less than or equal to 1. That's why we are taking this one. Okay, 0.75 is less than or equal to P of A union B union C is less than or equal to 1. So then, so 0.75 is the least one and the highest one is 1. So these two. Okay, so I'm expanding and apply the formula P of A union B union C. So this is 0.75 is less than or equal to 0.75 is less than or equal to 0.3, 0.4. P of A value is 0.3, P of B value is 0.4, and the P of C value is 0.8. P of A intersection B value is 0.08. P of B intersection value is P of B intersection C. So then P of A intersection C value is 0.28. P of A intersection B intersection C value is 0.09. So then the condition apply here. Then this value is 3 plus 4, 7 plus 8, 15. This value is 0.08. Okay, that is 0.23. 0.23 here value is 0.23 plus 9. Just simplify that one. So then you will get this value is 1.23. 1.23. So 1.23 minus P of B intersection C is less than or equal to 1. So 0.75 is less than or equal to 1.23 minus P of B intersection C is less than or equal to 1. Then, so I'm doing, so I want to find the only P of B intersection C value only. So P of B intersection C value only. So this value is, I'm subtracting each and every of the part of this one. I'm subtracting minus 1.23. So I'm substituting from this one. This will be 0. So this is nothing but 0.75 minus 1.23. 1.23 minus P of B intersection C minus 1.23. So minus 1.23 plus 1.23 gets cancelled. So is less than or equal to 1 minus 1.23. So that one. So just simplify. So this value is 75 minus 1.23 is nothing but minus 448. 75 minus 1.23 is nothing but 0.75 minus 1.23 is nothing but minus 0.48. And this value is 1.1 minus 1.23 is nothing minus 0.23. So just 3 minus are there, just to multiply with minus, then you will get like this. 0.23 is greater than or equal to P of B intersection C is greater than or equal to 0.48. So P of A intersection B, sorry, P of B intersection C value is 0.23 to 0.48. So that's why, so P of B intersection value belongs to 0.23 to 0.48. This is the finding. This is the solution for the given question. Okay. So once again, observe this question. So what is given the question? So ABC are three events. P of A value is given, P of B value, and P of C value. P of A intersection B value, P of B intersection C value, P of A intersection B intersection C value. So P of A union B union C value is there. So we know the condition. We know the condition, that is this one. This one. So 0 is less than or equal to P of A union B is less than or equal to C. So from that one, you have to apply the formula. This is the formula. P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection B minus P of A B intersection C minus P of A intersection C plus P of A intersection B intersection C. From that one, just you have to substitute the values. So, and the condition is this one. So you have to substitute. So this is P of A union B. Just replace this P of A union B, replace with this one, total this one. So just this one, this value replace with this one. So then you will get this. So from that one, you have to substitute the given values. Then you will get 0.75 is less than or equal to 1.23 minus P of B intersection C is less than or equal to 1. So from that one, you will get this one. Okay, so simplify that one. Then you will get the P of B intersection C value is belongs to 0.23 comma 0.48. Okay, right. Next problem. ABC are aiming to shoot a balloon. ABC are aiming to shoot a balloon. So A is here, and the B is here, and C is here. So I'm taking, so a balloon is here. Okay, so shoot a balloon. A will succeed out of four times out of 5. So A will, so decide, so 4. So total favorable cases by, so favorable cases by total cases. So favorable outcomes by total outcomes. Okay, so this is A will be hit like this. So out of 5 times, he will hit the balloon 4 times. Okay, so the chance of B shoot, the chance of B shoot the balloon is 3 out of 4. So out of 4 total cases. So total cases, this is favorable cases. 3 by 4. 3 by 4. Okay. Next, and that C is 2 out of 3. C is 2 out of 3. 2 by 3. So favorable cases by total cases. So this is given that if 3 aim the balloon simultaneously, then find the probability at least one of them hit the balloon. So 3 ABC are aiming the balloon simultaneously, then find the probability at least one of them hit the balloon. So at least one of them, which means at least one member will shoot, or 2 members will shoot, all the 3 members will shoot. So that is the question. Okay, so from the given, so solution for this one. So ABC are 3 events that ABC will shoot balloon respectively. Okay, so A will succeed out of 5 times, E will succeed 4 times. So that is, I'm taking P of A equal to P of A equal to 4 by 5. So 4 by 5 in the previous discussion. So then, so P of A complement is there. So if he hits 4 times out of 5, so how many times he will not? So 1 by 5. So that is probability of an A complement equal to 1 minus P of A. We know that P of A plus P of A complement equal to 1. So this is the condition. So from that one, we can find the anything value of P of A or P of A complement. We know the P of A value, then we can find the P of A complement. So that's why I'm taking P of A complement or A bar equal to 1 minus P of A. So P of A value is 4 by 5. So that's why P of A bar equal to 1 by 5. P of A bar equal to 1 by 5. So out of 5 times, you won't hit one time. You won't hit one time. Okay. So next, B will succeed 3 times. B will succeed 3 times out of 4 times. Out of 4 attempts. That is P of B equal to 3 by 4. P of B equal to 3 by 4. P of B bar equal to 1 minus P of B. 1 minus P of B. That is equal to 1 minus 3 by 4. What is that is equal to 1 minus 3 by 4, that is nothing but 1 by 4. P of B bar value is 1 by 4. And C will succeed 2 times out of 3 attempts. 2 times out of 3 attempts. So then, so P of C equal to 2 by 3 we are taking. So then P of C bar equal to 1 minus P of C equal to 1 minus 2 by 3. That is nothing but P of C bar equal to 1 by 3. Okay. So in the question, what is given that 3 members are there, A, B, C. So A, B, C will shoot the A balloon. That balloon A will shoot 5 in 5 times. E will shoot 4 times. So he will not shoot 1 time. Okay. So he will miss the target 1 time. So he will hit the target 4 times. And the B will succeed 3 times out of 4 attempts. So he will succeed. He will hit the 3 times out of 4 attempts, and he will not hit the target in 1 time. So out of 4 times. And the C will be the same. So 2 times he will hit out of 3 attempts. So 1 time he will not hit the target. So this is the given. So now we have to find. So A, B, C are independents. Here A, B, C are independent. So if A, B, C are independent, means P of A intersection B intersection C equal to this value, P of A into P of B into P of C. This is the condition for the independent events. So independent events and ABC are independent events. That's why so the probability of at least 2 of them hit the balloon. I'm taking the probability of at least 2 of them balloon. So this value. So P of A intersection B intersection C bar plus P of A intersection B intersection B bar intersection C plus P of A intersection B intersection C A bar intersection B intersection C plus P of A intersection B intersection C. So I'm taking, so at least 2 of them will hit. At least 2 of them will hit the target. So for that one, so I'm taking the first time C won't hit the target. C may not hit the target. And the second time I'm taking B may not hit the target. And third time I'm taking A may not hit the target. And fourth time, so 3 will be the hit the target. Okay. 3 will hit the target. So then this is the condition. So, and we know that ABC are independent. So from that one we can apply this one. So in the previous one, so that is, so this is P of A into P of B into P of C bar plus P of A into P of B bar into P of C plus P of A bar into P of B into P of C plus P of A into P of B into P of C. So then so P of A value, we know that value is 4 by 5. Okay. So P of B value is 3 by 4. So P of C complement is there. So actually P of C value is 2 by 3. But so complement is there, that is 1 by 3. So this is P of A value. And this is P of B value is here, and here P of B complement. That value is 1 by 4. So 3 by 4, this is 1 by 4. This is P of C value 2 by 3. So then similarly apply. This value is P of A complement. This value is P of B, P of C. And this value P of A into P of B into P of C. From this one, I can take. So 5 into 4 into 3. 4 is a 12, 5 is a 60. 60, numerator is 12. So 12 by 60, this value, only this value is 12 by 60. Observe this one. So 4 into 3, 12. 12, 5 into 4 into 3, that is 60. Plus this value, 4 into 1 into 2 is nothing but 8 by 60. Same denominator. So this value is 6 by 60. This value is 6 by 60. 6 by 60. Okay. This value is 24 by 60. 4 into 3, 12. 12 into 2, 24. 24 by 60. Just LCM is all are 60. Then I'm taking it 60. So then that value is 30. This value is 30. This value is 20. 30 plus 20. 50 by 60 is nothing but 5 by 6. 5 by 6. So the probability of at least two of them hit the balloon is 5 by 6. At least two of them hit the balloon is 5 by 6. This is the answer. So here given that independent events are there, so the probability of at least two of them hit the balloon. So I'm taking one will not hit the balloon. So two are hit the balloon, so one will not hit the. So first time, so I'm taking these three is for that one. So the last one is three will hit the balloon. Three will hit the balloon. So whether because of it says that at least, that's why we are taking this one. Okay. So just apply the formula. So independent events formula is nothing but P of A intersection B intersection C equal to P of A into P of B into P of C. So just apply the formula here. Thank you. Next problem. So in an experiment, drawing a card of a random of a from a pack, the event get a spade is denoted by A, and the getting a pictured card is denoted by B. Then the find the probability of A intersection B and A union B. So in an experiment, so drawing a card, drawing a card. So then, so from a pack, it says that so the event get a spade A. So if I will get the spade is the card, then that is the event A. If I get the picture card, that is B. So that is B given that. So then solution for this one. Before that, we know the how many cards in the pack. How many cards in the pack? So actually 52 cards will be there. So that are so and 52 cards and which four sets is there. So that is spade, club, diamond, okay, as, right, sorry. Then the cards are like this: A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, sorry, this is J, Q, K. So totally, if I'm taking a spade here, spade, so these spade, so these are four types, not spades. So spade, club, diamond, that are four types. So four types. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Totally a set has a 13 cards. A set has 13 cards. In that 13 cards, four are letter cards. Four are letter cards. So then next in this one, three are picture cards. So what? Three are picture cards. And remaining 9 is there. So 9 are number cards. Sir, what are the letter cards? What are the picture cards? What are the number cards? Numbers cards is nothing but showing the numbers on the that one. So that is nothing but this one. This is 9. Okay. So next. So here, this is letter cards A, J, Q. So here letter nothing but A, J, Q, K. These are letter cards. What are the picture cards? So J, Q, K are the picture cards. So these three are the picture cards. These four are the letter cards, and the remaining 9 numbers are that is the number cards. Okay, spade. So and the question that the event getting a spade is denoted by A. Okay, so from that one, so picture card getting, that is B. So number of ways of drawing a card from the pack. So totally how many is there? 52 is there. I'm selecting one out of 52 cards. I'm selecting one, that is 52C1. 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 That is 52C1 is nothing but 52 as per the combinations formula. NCR equal to NCR n factorial by n minus r factorial into r factorial. So then apply. So A and B are the events, the getting spade and a picture card respectively. So A pack consists 13 spade cards. So A pack consists 13 spade cards. Okay. So out of 13 cards, I'm selecting only one card. Out of 13 cards, I'm selecting one card. So out of 52, actually I'm taking out of 52 cards. Out of 52 cards, I'm selecting one card. So that card will be the cell, that card will be the spade. So spade is there. So spade is nothing but spade having the, how many spades is there? 13 spades is there. 13 spade cards is there. So then out of that one I have to select. So that is 13C1. So n of a equal to 13. So this is nothing but 13C1, sir. So this is out of 13 cards, I'm selecting only one card, whatever it may be. That is a spade. That may be A1, 2, A2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Any of them. So it will be a number card or the letter card or the picture card. I don't know. So what it I have to take a spade card from the 13. So I'm 13C1. 13C1 is nothing but 13. This is the number of A. N of A is nothing but, and the probability of an event A equal to, the probability of an event A equal to N of A by N of S. So N of A value we know that, N of S value also we know that, then just substitute the values. 13C1 by 52C1. So 13C1 is nothing but 13. This value 52C1 is nothing but 52. That is nothing but 52. 13 by 52. 13 by 52. Okay, this will be may write as P of A equal to 1 by 4. P of A equal to 1 by 13 fours. 13 fours. So 1 by 4. 1 by 4. So next, a pack consists of 12 picture cards in 4 suits. So 12 cards is saying that, sir. How many out of 52? How many types is there? How many shoots is there? 4 shoots. So 4 shoots. So in that one, I want to take only picture cards. How many picture cards in a 3 show? In a shoot, that is 3. So each having 3 picture cards. So total how many? 12. So 12. So this is 12. A pack consists 12 picture cards in 4 shoots. So spade, diamond, club. So that are, so having that, and one thing is there. So these are picture cards. So picture cards. A pack consists of 4 picture cards. Sorry, 12 picture cards. A pack consists 12 picture cards in 4 shoots. In 4 shoots. Then, so I have to select n of b value. N of b value. Where is this? N of b. So I'm taking here in the question given that, so picture card selecting, that is a b event as a b. So that is a pack consists of 12 picture cards in 4 suits, that is n of b equal to 12. N of b equal to 12. So then, so probability of event b, probability of event b. So probability of event b is equal to number of, I mean, n of b by n of s. N of b by n of s. So then, what is the n of b value? 12C1. Actually, 12C1, sir. 12C1. So 12C1 out of 12 picture cards from a pack, you have to select one card. So that's why that is 12C1. 12C1. This value, this is 12C1. This is nothing but 12. This is nothing but 12. So just substitute 12C1 by 52C1. 12C1 by 52C1. So this is the probability of an event. Probability of an event getting picture card. So that is n of b by n of s, that is 12 by 52. So you can, you have to reduce, simplify this one. This is 4 3 is a 4 13 4 is a, okay. So p of b equal to 3 by 13. So here in this one, a pack consists 12 picture cards. So 4 shoots are there. So 4 shoots are hearts, diamonds, spades, and clubs. Hearts, diamonds, spades, and clubs. Hearts, diamonds, spades, and clubs are there. So next, now there are 3 picture cards in 13 spade cards. There are 3 picture cards in 13 spade cards. So number of A intersection B equal to 3. Number of A intersection B equal to 3. Then P of A intersection B equal to number of A intersection B by number of S. That is P of A intersection B equal to 3 by 52. 3 by 52. So now P of A union B equal to P of A plus P of B minus P of A intersection B. This is the condition, addition probability theorem. Addition probability theorem. So P of A union B equal to P of A value 13 by 52. P of B value is 12 by 52. Minus P of A intersection B value 3 by 52. So previous one. So this value, I'm taking these values. So no need to simplify. So I'm taking that values. So this value and this value. So simplifying, simply simplifying. So then I will get this. Okay, P of A intersection B is 3 by 52, and the substitute the values here. P of A union B equal to 13 by 52 plus 12 by 52 minus 3 by 52. So take LCM as 52. So 13 plus 12 is 25, minus 3 is nothing but 22. 22 by 52 is nothing but 11 by 26. That is the P of A union B. That is P of A union B. So this is the answer. So this is given that in experiment we have to select a pack, select a card from the pack that that is a spade is a denoted by A and the picture is denoted by B. So from that one we have to take that one. So spade totally which has a pack having the 52 cards that has 4 sets, 4 suits, that is hearts, diamonds, spades, clubs. Each one having 13. So from the 13, so 4 letter cards and the 3 picture cards and the 9 number cards. From that one, so he says that picture card. If you take the picture card, that is B. So if you take the spade card, that is P of A. So P of A equal to 1 by 4, P of B equal to, so P of A equal to 13 by 52, P of B equal to 12 by 52. So then P of A intersection B equal to, so 3 by 52. Then substitute the addition probability theorem state in that one. So then you will get P of A union B. So this is the answer. So next question. So ABC are 3 horses in a race. So most important question for IP. So the probability of an A to win the race, is twice that of the B. So and the probability of B twice of C. So what are the probabilities of ABC to win the race? So clearly says that, so A is win 2 times of B and B is win 2 times of C. So that is nothing but we have to find the races, win the race, ABC to win the races. So then given that this one ABC, sorry, here ABC are 3 horses. Here ABC are 3 horses win the race, representing as events of ABCs respectively. So then given that the probability of A win the race is a twice of the B. A win the race is a twice of the B. Probability of A equal to probability of 2 into probability of B. That is equation number 1. So probability of B is twice of probability of C. So that is P of B equal to P of C. So this is from the data. So now just you have to substitute the P of B value in this one. And you know that P of A plus P of B plus P of C equal to 1. Some of the all the probabilities is equal to 1. Okay. So then from 1 P of A equal to of P of 2 into 2 P of C, then that is P of A equal to 4 of C. So then we know that P of A plus P of B plus P of C equal to 1. Then so now we have to transform all the values into P of C. So P of A value is here. So that is P of 4 P of C. And the P of B values, where is the P of B value? Here. So P of B value is 2 P of C. So and the P of C value is P of C. So just substitute the values. So then 4p of c plus 2p of c plus p of c equal to 1. So 4 plus 2 plus 1. So 7. 7p of c equal to 1. 7p of c equal to 1. Then p of c value is 1 by 7. So c will the race out of 7 times. It will be only one time win the race. From 3. So that is p of a equal to this value. From this one, p of a equal to 4p of c. So then just you have to substitute the 1 by 7 value in this one. Then you will get p of a equal to 4 of 1 by 7. So that is nothing but p of a equal to 4 by 7. So a will win the race out of 7 times. It will win the race 4 times. It will win the race 4 times. So now from 2. So p of b equal to p of c. P of b equal to p of c. Just you know the value of p of c. Then you have to substitute there. Then p of b equal to 2 of 1 by 7. Then p of b equal to 2 by 7. So p will win the race out of 7 times. It will be 2 times. Okay. This is the winning the race. So p of a is 4 by 7 times. 4 times out of 7 times. P of b is 2 times out of 7 times. P of c is 1 time out of 7 times. Okay, this is the answer, and a simple answer, and a very, very important for IPE. So please observe once again this one. So this is, so ABC are 3 answers in the respective events. So ABC respectively. So given P of A equal to P of B, this is the condition given that. So P of B equal to P of C, equation number 2. So we know that P of B value substitute in the equation number 1. So then I will get P of A equal to 4p of c. From, I know we know that p of a plus p of b plus p of c, sum of the probabilities are all equal to 1. Okay, so from that one we can take the values into p of c and substitute, and the p of c value is 1 by 7. So and the substitute that values from the 3, from in 3, then you will get p of a value. In 2, then you will get p of a value. So this is the required answer. P of a equal to 4 by 7, p of b equal to 2 by 7, p of c equal to 1 by 7. So next question, if A and B are the two events with the P of A union B equals 0.65 and the P of A intersection B equals 0.15, then find the value of A in complement plus B complement. So here given that two events are there, so P of, then P of A union B is given and the P of A intersection B is given. So then we have to find P of A intersection, so P of A bar plus P of B bar we have to find. So given that you have to write. So then P of A complement plus P of B complement. We have to find this value. We have to find this value. So A complement, that is nothing but P of A plus, we know that P of A plus P of A complement equal to 1. From that one, so I can write, so P of A value, then you have to take this values to right side. Otherwise you have to find the P of A complement, then you have to write 1 minus P of A. So here we have to find the P of A complement plus P of B complement. So for that one I can write P of 1 minus P of A, 1 minus P of A, this value is 1 minus P of B, 1 minus P of A, 1 minus P of B. So that is, this is a, okay. Next what is this? 1 plus 1, 2. So P of A complement plus B of B complement equal 2 of minus taking common, then P of A plus P of B. So we know that. Okay, we can use this addition property theorem here. So P of A complement plus P of B complement equal 2 minus. So this value is nothing but from this one. Just I want this one only. Just I want this one. So I have to take this into left side. I have to take this into left side. Then I will get minus is here. Then I will write this value is P of A union plus P of B. So A union B plus P of A intersection B equal to P of A plus P of B from addition probability theorem. Okay, so then I can write these values P of A union plus P of A intersection B. Why? Because of here we have the these values only. That's why I'm transforming into this one. So then substitute there. So P of A complement plus P of B complement equal to minus 0.65 of 0.65 plus 0.15. So that is the values of P of A union B plus P of A intersection B. So then P of A intersection B in P of A complement plus P of B complement equal to 2 minus this value is nothing but 0.8, 65, 15. So there is 80. So here 0. Is there, so the 0.8. So from this one you can get P of A complement plus P of B complement equal to 1.2. 1.2. This is the answer. So just use the addition probability theorem. So transform to required one. Okay. So if the A and B are independent events, P of A equal to given 0.6, P of B equal to 0.7, and then find P of A by B, P of B by A, P of A union B, P of A intersection B, which is nothing but conditional probability theorem or multiplication theorem. We can find this one as per that one. So then, so given that A, B are independent events, P of A, P of B, given that, so P of A intersection B equal to P of A into P of B. So P of A intersection B equal to 0.6 into 0.7, that is 0.42. Okay. Then, so P of A by B, first question, we have to find this value. So P of A by B from the conditional probability theorem. So then P of A intersection B by P of B, P of A intersection B by P of B. So we know the P of A intersection B value and P of B value. So just substitute the value. So 0.42 value of this one and the P of B value 0.7. Then you will get 0.06, 0.06. Okay. Next. So similarly, P of B by A, P of A intersection B by P of A. Substitute the values. Then P of B by A equals 0.42 by 0.6. That value is 0.07. P of B by A value is 0.07. So then we have to find the P of A union B. P of A union B is nothing but P of A plus P of B minus P of A intersection B. This is the additional probability theorem. So then P of A union B equals 0.6. That is nothing but P of A. P of B value is 0.7 and the minus 0.42. So then this one 1.3. This value is 1.3. So minus 0.42. Then you can write 0.88. P of A union B equals 0.88. So then now, so this is a solution. Okay. So we already, so given that P of A value, P of B value, we have to find the P of A by B, P of B by A, P of A union B, P of A intersection B. So these two are independent events. He mentioned that. So that's why we can take it like this. So we can find the value of P of A intersection B and the P of A by B from the conditional probability theorem. So P of B by A is from the conditional probability theorem formula. So then P of A union B from the additional probability theorem. Then you will get the required answers. Okay. So now assignment. If A speaks truth in 75% of the cases and B in 80% cases, so what is the probability of that their statements about incident do not match? So A speaks 75%. A speaks 75% correct. So truth. So which means A does not speak 25%. A speaks wrongly 25%. So B speaks 80%. 80%. So 20% wrong. So you will be wrong. So what is the probability of their statements about an incident do not match? So nothing but you have to find. So A speaks 25% wrong and B speaks 20% wrong. After of that one, you have to find the probability of their statements about do not match. So if A speaks correct and the B speaks wrong. So if B speaks correct, A speaks wrong. So that is you have to find. These are independent events. Next. So last question. A problem in a calculus is given to two students A and B whose chances of solving are 1/3. So A solving in 1/3, so B solving 1/4. Find the probability of the problem being solved by both of them try independently. So just problem is given. So P of A equal to 1/3, P of B equal to 1/4. So find the probability of the problem being solved. Both of them try independently. Independently is nothing but here he given that this is independent events. P of A intersection B equal to P of A into P of B. So then P of A value is there, P of B value is there. So P of A bar, P of B bar. That's why you can find that one. Simple problem. So this is the last question, and this is a close probability. This is the probability. So all the best, students. Thank you, sir. So Javed sir.